Hi, my name is Tom Utiger. I'm with IBM Services. I'm part of our public markets practice area, focusing mostly on healthcare and life sciences project. I am part of the AI and machine learning practice, so we get to do all the cool and exciting data science work that's out there that our customers have need for. So I've been with IBM for about 11 years, and in my time at IBM, I've worked in a variety of different practice areas and doing different types of projects for clients over the last 11 years. Prior to IBM, I had my own specialty consulting group that specialized in information governance for about 8 years. And before that, I had a blast doing video game development. Had another startup of my own where I did some console development for PlayStation and Sega Saturn. So very exciting work in there. These days, I live in Middle Tennessee, which is just a little south of where you guys are in Louisville. And I spend a lot of time with my family, my wife, my 3 kids, a couple of dogs, and I'm an avid startup fan, helping local companies get their startups off the ground, and I help a lot with Boy Scouts. During this time, feel free to post questions in the chat. I will be answering questions in the chat. So as they pop up with things I say or other questions, go ahead, post the question. I'll be sure to try and get that answered. Maybe if not with a right question, at least a humorous answer to your question. All right, so I work for this little tiny company, International Business Machines. We've been around for just a touch over a century. In that time, we've done 1 or 2 things that may have had a little bit of impact on the world. The punch card, everyone's favorite. We got started with that in the 1880s. One of our predecessor companies, which got merged together in 1911, created the first punch cards, and of course we standardized it. We were participating in some of the first computers like the Harvard Mark I. We built some of the first computer languages like Fortran, which is still around and some people are still using it. Sabre, which was the first airline reservation system for American Airlines. We helped with a couple of those little space missions you may have heard about, like Mercury, Gemini, Apollo. And you may have seen in Hidden Figures recently them talking about the human computers taking over to support the IBM computers, and as the years have progressed, so we've had quite a bit of impact in our time over the last 100+ years, and of course we've brought many exciting advancements to the world of education, like the Scantron. And everyone in school has always enjoyed the Scantron. So you have IBM to thank for that. Just a quick view of who IBM is and how we've changed over the years. We really started out as a hardware company. Software really didn't exist a long time ago. It wasn't really until the invention of the IBM mainframe that you could create portable software that can move from hardware platform to hardware platform. Before that, everything was super custom. Each computer was different. The programming was done very manually. And of course, we started back in the day, and we've mostly been doing hardware. As time has progressed, we slowly began developing software. We really got into the software into the 1980s. And then, of course, you'll see this line here starting in about 2010. This is where we really stepped into the world of AI. Now, we didn't call it AI because at the time, and you talked about AI in a business context, companies would laugh you out of the room. So we created this term cognitive. So we, rather than talking about AI and people say, "Ooh, that's crazy. That's weird stuff. That's not real. We can't bring that to the business world." We started talking about cognitive computing. We had gone and created Watson to go and crush those humans on Jeopardy, and that created a real interest that, wow, AI has something going for it. But we called it cognitive computing so that we could actually go and have good, strong, solid C-level conversations with folks. And Then, of course, our competitors out there went ahead and decided that they needed to differentiate themselves from IBM, so they started calling it machine learning and AI. Back to where we were differentiating ourselves. So, in the last year, we've really focused. We have really made this an important part of our business, not just for our customers. Right now, we're doing half of our business with some form of hybrid cloud and cognitive or AI as part of the business that we do with our customers. And it's a huge amount of business in an organization like IBM. We're also applying it to ourselves. We're also transforming our organization so that when we talk to our customers, we can say, yep, see, we just did that last year, and look at the value it's bringing to us. So this is some of what's important about understanding where we're going. It's not just that we're talking about it, we're also delivering it to our customers and applying it to ourselves. So here you are, going to school, working on a degree, most likely in data science, possibly in computer science. Also, maybe you're doing something outlandish like linguistics. What do you need to learn in order to be a good data scientist? Well, our world of data science it's quite broad and complex. There's no way for you to learn it all. Within data science, we have many subspecializations. We have people that focus deeply on data. And they have other people that focus very much on computer vision, doing lots and lots of computer vision work. We have other people that focus on natural language processing. And then we have other folks that do lots of statistics, and the list goes on. You can't learn all of it, but you can learn to specialize, and you have to specialize. You develop some deep skill in one of these key areas, and then, of course, you need a series of other skills to be around that world of data science so that you can be conversant, know how to connect to those other domains of data science, and bring it all to bear. Also, most importantly, data science does not live in a silo. You got to learn computer science. You have to learn computer engineering. The software engineering is important. Most of our projects, if we're doing smaller, bit-sized AI experiments, those are great. We can live almost 100% within a data science world. However, as we move into putting something into production, you suddenly need all kinds of other skills, and you need to be conversant with those skills. And so we're going to touch on those as we go along. One of the other things that's really important is just you need a skill, some kind of domain knowledge, something other than computer science and something other than data science. You need to know public health policy, public speaking, or in some cases, linguistics. Linguistics is a great example of something you need knowledge of in order to make natural language processing work. I have had projects where I've worked with, taught the linguists, hired somebody onto the project team who was a linguist, or maybe had a deep skill in Latin or ancient Greek, and because they understood linguistics well enough, I could teach them enough to be useful on the projects around data science. And so that knowledge of the domain of linguistics matters more, and then you bind that with your data science skill, and then you can generate value. So it's really all about generating value for whoever your customer is. That might be, you might be working for a company, you might be working for customers, but you need to learn all of that not data science stuff that makes all of this possible, and these projects really exciting to work on. So also, you can need to learn to be curious, you need to have deep thirst for knowledge, and of course, most importantly, you need to be helpful. This is kind of an odd advice, but we live in this space of machine learning and AI, and people look at us and they don't understand what we're talking about. And so you have to step back from our world of being the data scientist in your lab coat approach to the world, and you need to open up and help people understand enough so that you can communicate back and forth effectively, so they can meet you halfway and you can meet them halfway. So be considerate and helpful. It will go a long way, and it's a strange thing to say about data science, but it's actually one of those soft skills that we find incredibly important. Speaking of soft skills, critical thinking. I can't stress this one enough. Critical thinking, critical thinking, critical thinking. Also, learning to communicate, tell stories. How do you communicate? Via email, via a write-up, via a presentation, stand up and give a public talk. These are incredibly important skills. Teamwork as well. How do you work as a team? I have one of the people that works for me on a project. I asked him, so what makes a good data scientist? And his comment back to me was, well, what makes a good data scientist is a good data scientist will wake up in the morning and go check Jira to see what tickets are pending that have been assigned to him. Go get those tickets taken care of rather quickly, make sure it's all good, make sure nobody else has any problems, and then go check to see if some job that he had running overnight or some notebook he had running overnight crashed and needed to get fixed. He said, and then his comment was, a bad data scientist will get up in the morning, check to see if his notebook had crashed, then spend hours and hours and hours on Stack Overflow and trying to find an answer to his problem, and then realize it was something incredibly silly and have wasted most of the day, and then finally get around to his Jira tickets. So it's a question of how do you work well with team members. So really important. Something else that's really become very important at IBM and also across the broader portion of the software industry is this idea of design thinking, user-centric, a user-centric approach to how on earth do we create software for folks. And so we'll touch on this a bit later. And then, of course, software engineering. You must learn the basics of software engineering because these days AI is being infused in vast amounts of software, and the software engineering skills are infinitely important to making those projects successful. And of course, take some fun classes in odd stuff like handwriting. When you show up and have beautiful calligraphy, that's awesome. Philosophy, ethics, Egyptology. Who doesn't like studying mummies? And of course, my favorite was, of course, when I went to school, I took Norse mythology, and this, of course, helped me with my children when the Avengers came out, because I could keep up with and tell them more about Asgard and Midgard than they knew, and of course, that made me slightly cooler than they were. And of course, Latin. I keep coming back to this idea of linguistics. We like to talk about natural language processing. Your understanding of how language and how to manipulate language becomes really important as we're doing these data science projects that are not statistics centric or raw number centric. When they're dealing with language, whether that's in English or Spanish or pick your language of choice, whether we're doing that in a spoken language or we're doing that in a written language, the ability to understand how language comes together and how you manipulate it really helps with making some of these natural language processing projects successful. Yeah. All right, so moving on to my first example. This is a project we did which will impact flight safety around the globe. There's this small little company called Flight Safety International. I had the privilege of working with these guys to put this project and this program together in its early days. So what we did is we built an adaptive learning experience for pilots. So how do you train pilots? One of the biggest problems that happens is that it takes hundreds of hours to train a pilot to become good. And the FAA looked at it as, well, if you have enough hours in the flight simulator seat and you don't crash that often, that qualifies you to fly a plane. And you may have to make sure that you deal with some of these, the various problems that occur on maybe takeoff or landing as you do these various maneuvers. So the idea really was a human. So as you'll see in this picture with the red window, with these red windows. So this is the red screen of death. and very important to not crash your plane. But there would be this instructor sits in the instructor seat in these huge flight simulators, and they sit back and they watch the pilots and they give corrective information back to the pilots, either in real time sometimes or later in a flight debrief of what went well, what went wrong. However, that instructor has a limited field of view. They can see pretty much what the hands of the pilot are doing, but not necessarily what they're doing with their feet and the pedals and things of that nature. They can maybe see the person tensing up, but they can't see everything that they're doing. What we did and what we were asked to do was, is there any way to get into these machines? Some of them have 500 sensors built in, some of them have a couple thousand sensors into it. And so there are already these flight simulators are instrumented with lots of IoT devices in there, spitting out vast amounts of data. So what we ended up doing was we had a team go in. They looked and identified which sensors we should work with. We found about 70 to 80 that actually gave us good information to work with. And then we did things like learned how to identify when somebody's turning left, when somebody's turning right. No, I guess I got that backwards. Turning right, turning left, and then where they're taking off, what their takeoff looks like, what their landing looks like, how they're dealing with various other things during their cycle of flight. And so what we did is we learned to deal with that. We then also learned we created a gold standard. So now we could take a person who is flying, the student pilot is flying, they do some maneuver, and we can compare that maneuver against a standardized best practice maneuver, and we can then score how well they actually did. And so this was truly amazing. And what we were able to do was create a system where we could see how well an individual student pilot was mastering the skill of flying these huge jets. Now, in that middle picture there, you see Andy. Andy is the pilot, is not the pilot. He's the person we put in charge of this program. And the reason is he's a pilot. He got his pilot's license. He got to have lots of free flight time, and under the guise of I have to test the system. He learned to fly these things, and we get feedback from the system, and really improved. So what we could identify were weaknesses that the student had, how they responded to certain scenarios. We could see if they're stomping too hard on a pedal under certain circumstances. And interestingly enough, we learned to identify students that we should wash out early, that just don't have the skill to fly these big jets. So this was really, really, truly an exciting program. And so we ended up with showing off these kinds of panels, these dashboards, to the instructors. So they would, we could score the students. We could now see how the individual maneuvers were, why they failed, what reasons they were failing, what maneuvers they should start working on because they're potentially weak in a certain area, or they've maybe mastered some basic skills and it's time to move them to more advanced maneuvers, what their overall sense of mastery was, what their progression trend, how we could wash them out, how they're doing compared to other students. So this became a way to actively measure the quality of a student as they're growing as a pilot. So very exciting work. And we built this for Flight Safety International. They have their customers. One of the first customers, if you noticed on the top of the page there, United States Air Force. We deployed this, and there has been several classes of new Air Force pilots that have had to go through this type of training, and the feedback that it has given has been invaluable for the team. So very exciting project. Not every project is like this. Not every machine learning project is as exciting and unique and transformative as this one is, but we do have these come up with regularity, and thought I'd share this one with you. So in order to do a project of that nature, we need to understand the business that we're working with. So we have a view of the market. And this is kind of a view of, and this is what data scientists do. So we do come in and we do take these tops-down view. We do understand where the organization is, especially when you're in a consulting group like ourselves. Our consulting organization really focuses on you needing to be a consultant first and a data scientist second and sometimes third. So the traditional enterprise really is, it's our old school enterprises. It's our corporations that they have some technology, they have it deployed, but it's not part of their who they are and what they're doing. So they do some experimentation here and there, or maybe they have their accounting system running. So we have lots of companies that fit into this category still today. What we've been advocating has been this concept of the cognitive enterprise for a couple of years here, which is this idea of you really need to bring in the technology deep into your organization. You need to combine the cloud technologies that are out there, some of these exponential technologies like AI, blend it together, drive some innovation through your organization, and really kind of move this digital from being pieces and parts of your organization into the center and make it core to what your company is. Then, of course, our next view of where the companies where our customers are going really is this idea of the virtual enterprise. And everything at this point has become digital. And so there are some companies that are moving very rapidly in this direction, where they are trying to blend humans and AI together, and they are bringing intelligence to all their workflows in their organization. They're very, very focused on growing the technology stack in a way that is a little different. And so that's where we would call the cutting edge right now. But we see companies moving in that direction, and we're helping a lot of those organizations get there. And of course, you as new data scientists joining our ranks in either this year, next year, in the next couple of years, you'll see more and more of this through your careers, as it's going to be less about the coolness of the AI and more about how does machine learning get infused throughout the processes of an organization. So this is what our clients struggle with. This is just this idea of there's all these pressures. You can put them in some major buckets, of course, technology, market, competition, and they're squeezing on the outside of these organizations. And there's global pressures, there's regulatory things hitting you, there's cost issues, there's social, there's new people, those new entrants in the in the marketplace that are trying to disrupt the company's business. Customer expectations, like one of the things is they say, we like to talk about is the last best experience a customer had is now the new standard that everyone has to meet. And so a lot of our clients are realizing this, that they just were able to go to Amazon and somebody went and clicked and was able to order something on their phone. And why can't your company, company X, why can't you do that? It's so easy. Amazon can do it. Why can't you do it? And so we get those kinds of conversations. And how do we help some of these organizations that might be hindered by regulatory barriers, that can't actually deploy some of these things? They might like to, but they can't for a variety of reasons. How do we work through that? How do we still create user experiences and get AI infused? And you'll notice AI is just but one of the technology pressures that's coming to bear. So people worry about how do they deal with all their different technology stacks? How do they get their old stuff to new? And of course, how do we get the mindsets? How do we get the skills of those companies' employees reframed and set for what we talked about, either the cognitive or the virtual enterprise, and as it comes up? So these are the big pressures that our clients feel on a day-to-day basis, and the pressure, it gets intense more and more and more as we progress. Now, we've taken that view of how do we saw that first thing, which was we saw those enterprises, the old traditional enterprise, the cognitive and the virtual enterprise, and then of course we've talked about those many pressures. But when it comes to a company, this is how they think. And what they have is they've got a business view of what this is. So Here's kind of an example of an electronics industry point of view, which is the CEO, CFO, whomever says, hey, improve business results. We need to do this. And how are we going to do this? You can either improve your capital efficiency. Maybe you can work on operating margins. Maybe that's increasing sales or reducing costs somehow. And then, of course, these then flow into a set of processes. And so there are all these processes in different industries. Different industries have different processes that come to bear. There are some generic ones that kind of go from industry to industry to industry and span all of them, say like some types of various processes in accounting. But this is where we begin to really focus as data scientists. We need to pick the client. The client may come in and say, I'm having this problem. We need to go and understand what that process is. So we need to have domain expertise in that space. Pick something, it might be supply chain, it might be energy usage within the organization, like maybe data centers cost a lot, or how do we they consume vast amounts of electricity. Maybe it's engineering or developing new engineering works for your company, building new devices, testing that all out. So there are all kinds of different processes that come to bear. Inside that process, there are opportunities to infuse it with AI. And this is really important, but you can't infuse the AI and the machine learning into that business process without some domain expertise. And so this comes back to, I'll come back to it over and over again, you need to develop some form of domain expertise around something within the business world that you're consulting on. It comes from, you might spend years at a company and you become really good at regulatory work. Maybe you become really good at, pick anything. I mean, maybe it's supply chain and we find ways to bring this in there. Or sometimes you may not have those skills, or you'll never have the domain knowledge, and you need to pair up with somebody who has the domain knowledge but doesn't have the machine learning skills, and you've got to learn to communicate and work together and have teamwork in order to actually drive to and improve that basic business process. So as this is where the reality meets the road with a lot of our data science these days. So how do we do that? We have this concept of the golden thread. This is a term we take from design thinking, and how the design thinking says that we need to focus on what is the user experience. They're coming into some process, they're trying to achieve some goal, and what is the best way that we can take them from where they are to the outcome that they desire. And of course, there are sometimes conflicting outcomes. Maybe they want to return, something. Let's say we sold them something, they want to return it. We want to minimize the returns, and so we might have some conflicting things. But how do we get through that cycle so that the client is happy and the company's happy at the same time? And so we create that golden thread, and it's focused on understanding the market pressures, understanding the outcomes, and then weaving it through the ecosystem that a company may have. They have lots of different systems that are there. And of course, we might do some IoT, we might do some AI, blockchain might be involved, lots of automation. And of course, we ideally layer it on top of a common data fabric, so our information that's flowing into the various processes is clean, standardized, and easy to use and consume and keep up to date. And of course, if we've got good data flowing in, we can then use that in our models to do better projections on interacting with those customers in the future and improve the outcomes there. So golden thread, it's an important concept in the world of design thinking. And you will hear more about design thinking as you begin to enter the working world, especially in large enterprises. You'll hear lots about design thinking. And I highly recommend that you dive deep into it before you graduate, learn about design thinking. So here's a project I worked on as well. Uh, this is a different style of data science. So everyone's worked with a chatbot. You've used a chatbot. You've used Siri. You've used Google Assistant. They have their good spaces. You've gone to various websites and you worked with the chatbots, and some of them have just sucked. Absolutely sucked. And in that, people didn't necessarily design the user experience. So this is healthcare. People are coming in here, they're often have a lot of stress going on in their life, and they are trying to get to a successful outcome. Be that they need to make sure the claim has been paid, or they need to find out the status of can they be pre-authorized for some procedure. And so we worked with Anthem, and we designed that golden thread for how people come into Anthem, how they interact via a chatbot, via a mobile app, or pick up the phone and call, have them really come in and work through that. Now we have members, people that actually consume and use the healthcare services. We have providers. Providers need to come in and ask questions like their doctors, their hospitals, and they need to find out if you're actually authorized to use, or how much of a copay they need to charge you, or things of that nature. We have employers that need to log in. Employers then need to come in and say, hey, so-and-so just had a new baby. We need to put them on the plan so that they can now get insurance. And of course, we have brokers, which are part of the healthcare payer ecosystem, and they work with smaller employers and provide a lot of management capacity around that. So how do you create these chat interactions and make them work well so that people have higher customer satisfaction scores? This was our key thing, is how do we make it so that people aren't frustrated and just go agent, 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 or human, 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 or something. They want to bypass the chatbot because their previous experience has been so bad. So that's one of the things we worked at. So with a tool like Watson Assistant, which was at the core of this, and Watson Assistant is IBM's virtual agent tool, it became the tool that we used to drive this experience forward. Interestingly enough, we took as much of the data science out of Watson Assistant as possible. We tried to create tools so that we could have business analysts focus on creating that user experience and not worried about coding. Do I need to tweak a model? How do I tune this? How do I tune that? We still had quite a bit of data science on this. There are some still things like speech to text, text to speech that do require more tuning and training of models. But most of this work is all linguistic centric. It's not tuning a model that requires you to understand statistics and things of this nature. It's really about understanding language and how does language work? How are the multitudes of ways for people to come in and ask the same basic question and get to an intent of what they're looking for, and then that can then drive to some workflow that helps drive them to a successful outcome. Like, hey, I want to look up my claim. What's the status of my kid's claim? Why didn't it get paid? I paid that. Why? There's those questions. Or do I get this benefit? Hey, I'm going in for this type of surgery. Is it covered, or how much of it is covered? So lots of things like this. Very exciting. This link down here, you can listen to our customer here at Anthem. He will happily chat. He talks about how we built it out, the things that we did. And it's a 4-year program. We've been into this program with them for a couple of years now, and they're having huge positive customer satisfaction back for this. So 1 in 8 of you somewhere in this class or in this webinar probably have Anthem as your healthcare provider. So check it out. They have a mobile app called Sydney. It does the chat, or you can go on the website and do chat. And soon we're rolling out voice-based AI with it as well. This one was an interesting, quick project. The client showed up to us and they said, we need to stand up a voice virtual agent in 3 weeks. There's an announcement coming out that we are going to be one of the providers for COVID shots and we have a 500-person call center. It's going to get overwhelmed with the phone calls that are coming from all over the country. What can you do? And from design to go live, 3 weeks, we stood up a virtual agent that took in millions and millions of calls. So when they first launched and the first announcement first came out, they were overwhelmed. People sat on hold for 5 hours, 6 hours. It was crushing them. We turned the virtual agent on. 70% of the calls got handled by the AI. Clients were happy. The customers were happy, and the call center volumes dropped down to something reasonable that could actually be handled. So sometimes it's fast and furious, but always interesting with this is everything we do goes into production. And so we always have a laser-like focus on how do we get our data science into production. So this is one of those issues. How do we get stuff into production? And so most companies out there are struggling with this idea of how do we get past basic experimentation. Hey, we hired these data scientists and they're sitting around and they're playing with this thing called Jupyter Notebooks, and they're doing some cool experiments and everything, but it's costing me lots of money and it's not going into production. So they're just saying, I'm not seeing the value of data science. And so these are actual quotes from customers that don't understand how to apply machine learning in their organization. And they started off where most customers do. They start off here. This is our typical story. We've talked to I don't know how many customers about this. They have a grand idea. Hey, wow, AI is super special. Let's get something and deploy it. It's going to be magic. It's going to be a silver bullet. And of course, they bring in some data science people, and because they're scientists, they're clearly going to be smart and they're going to do all this cool stuff. So they try to do something, and of course, the directives they're given, the team that gets stood up to do it, more often than not gets told, go do these magical things, and they do lots of data science experiments. And these data science experiments, in and of themselves, are really cool. They solve a problem. But what they don't do is they don't make it into engineering. And after a while, there's this big cost that begins to build up, and then we reach the moment of truth. The moment of truth is when somebody says, get rid of this data science team. They're absolutely worthless, of no value. Let's go back to the way we used to do software engineering and not bother with this data science. And there goes the data science team. Maybe they get laid off. Maybe they get folded into the basic software engineering team. Who knows? And we, of course, enter the long, dark tea time of the soul, where people are going, we did some data science, but it didn't do anything for us. And then they become gun shy. They don't understand why it didn't work. And this is where, somewhere along the line, somebody gets enterprising, successful, maybe inside the company. Somebody chats to a friend at another company, says, this is how we did it, and we were successful about bringing it. And they don't call it a data science project. They just call it a software, some software engineering project, and they add a little bit of data science, but nothing big, right? And suddenly it's successful. And then the momentum begins to build upon itself. So the key here really is the combining of the data science with the software engineering and bringing it together to get something into production that is creating results. Now, sometimes some of those results that make it into production have made big headlines in the story because the AI has done exactly what you told it to do, and you never gave much thought to the impact of what that would do. And of course, leads to questions like ethics in AI. What are you doing? Well, this makes no sense. This was wrong and cruel. A human never would have done that. But how we train things, how we think about things, and this has a lot to do with data science maturity in an organization. And so then we begin to put in forensic technology, begin to develop a culture around how to build AI properly, and then we reskill teams, we set teams up, and then of course we eventually build toward this concept of a trusted AI and getting that deployed within the organization. So we see this over and over and over again. Very few companies manage to start here, the all-knowing AI, and make it up this curve here without hitting the stumbling block. Some companies like to hit this stumbling block multiple times, and they go over it back and forth, maybe in different parts of the company at different times, and eventually they do make it here. We're beginning to see more and more companies realizing that they have to bring these two disciplines together in order to get to success. So as we operationalize AI, we have the people that engineer things, we have the people that deploy things, we have the people that monitor things, and then of course we have the trust and transparency. And they go in a circle over and over and over again. With machine learning projects that we deploy, this is not like old software engineering projects. You build the project, you put it into production, you have a couple of people maintain it, maybe reboot the software once in a while, and it was done. With our AI projects, this is something that upper management is slowly learning, is there's lots of TLC, lots of tender loving care that needs to be poured into these AI systems on a regular basis to account for drift. Model drift is how do you detect it? How do you find it? How do you do things? Things like virtual agents, there's almost a continuous change in human language happening. So you're not accounting necessarily for model drift. You're accounting for language change or business change, new terminology. Hey, we've got a new marketing program. We've got to now take all that new marketing information, fold it into what the AI is hearing from the end users, so that we can now account for and make sure it's routing stuff to the right place so that we can properly answer. So this goes all around here. And you'll notice out of this, under the engineering side of this, there's only one bucket that says model development. This is one of the things I keep running into with new kids that join our consulting practice, is they all want to dive deep into model development. And they go, when do I get to really get into model development? It's like, well, we maybe spend 10% of our time working on that with projects. We got all these other cool things that we got to do in order to get a project through to production and actually delivering value to the end user. So that's an important thing, is to understand these all depend on each other, and they go around and around and around in circles quite often. That. All right, so what kind of degree do I need in order to be a data scientist? So this one comes out often, and of course it's different for those of us that may have a little bit of possum blonde in our hair, but I'll deny that I have any of that. The gray hairs versus the fresh out of school. So back in the day, there were no data science degrees. In fact, 11 years ago, when I first joined IBM, you had to have a PhD in mathematics in order to join the data science practice. If you didn't have a PhD in mathematics, thank you for playing, goodbye, and off you went. The data science practice the practice of data science has since matured a lot. And as a result of that maturity, lots of tools have grown up. You no longer need the depth of mathematics that you used to need, 10 years ago. These days, you can still do data science now, and you don't need to know as much. You don't need to know as much about mathematics. In fact, sometimes you're better off knowing linguistics, as I'll point out several times in this talk. So these are some of the degrees I've seen. Some of my coworkers have degrees in computer science, absolutely. Degrees in statistics, math, physics. I happen to be a physicist by trade. Chemical engineering. Medieval history. This is a good one. Medieval history. And I have a friend who's a data scientist that has a degree in medieval history. One of our distinguished engineers, she has a degree in archaeology. So that degree has come in quite helpful in the space of data science. Another one is classics. So classics is ancient Latin, ancient Greek, and the learning and the speaking of that. Of course, those people do really well on the natural language processing side of data science. Degrees in linguistics. I know of at least one guy who has no degree and managed to flunk out of high school. And yet he still is a rock star data scientist. I don't recommend this path these days. You have the automated tools that are kicking you out if you don't have a 4-year degree on your resume. So the fresh out of school side of life, data science, computer science, math, statistics, these are all great, solid degrees that we need. Linguistics, highly recommend linguistics. So for those of you who know a linguist, data science is a great place to be. Recently, I just hired this woman to our practice. She had a degree in linguistics and had been out teaching. She was actually a teacher, would teach English as a second language, and started doing Python on the side to try and help do the rating and scoring of reading levels for various students. And she kept adding, because she had domain expertise in linguistics and teaching, she did a much better job and created a really cool little program to improve how you actually score reading levels. So, for those of you who have kids or will have kids in the future, all those books, those little kid books, have these reading levels of 100, 200, 300. And she created an automated tool to do a better job of identifying what the appropriate reading level was. So linguistics is an interesting place, and to get data scientists. Design thinking, incredibly important practice. One of our better data scientists, she moved over from our design practice to do data science, and she's awesome. She may not have the depth in mathematics that some of our other folks do, but she rocks when it comes to data science. And of course, fashion merchandising. Who doesn't like fashion merchandising? So this is speaking to Elle Woods from Legally Blonde, but and I make fun of this, but we actually have a fashion designer. One of our fashion designers is one of our lead designers in our public markets practice, and he brings a lot to bear with how to design these AI systems and bring them in there. So it's really amazing. If you want to do the hardcore deep data science, there are roles for you. If there are other roles that are data science light, you may not be really a data scientist. You may be more of a machine learning analyst, business analyst that focuses on machine learning solutions. And we find a lot of these roles can be filled by people that have other degrees and have some other domain expertise. I'm going to stay on this one very, 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 very lightly because there's a lot of information on here, and you can read this after the fact. But fundamentally, this falls into, in order to enable data science in big companies, you have to create a standardized execution model. And this is really important because it's the daily execution model. You don't want to spend all your time doing those little AI experiments we talked about earlier. We want to focus on do it once, do it right, make sure it can go into production. As an example, we stopped doing things with notebooks. Notebooks are great. They were great for a long time. Now it's about getting your chunk of code into production. So what do? Rather than playing a notebook, I sit down, open up PyCharm, write a Python script right there. If I can get it to work, great. Now I can put it into a pipeline, a DevOps pipeline, and throw it into a Kubernetes container, and then that'll get deployed. So if I start in a notebook, I have to waste all that time because now I still have to write that Python script, and because now we're deploying everything in Kubernetes. And so another thing to pay attention to is Kubernetes pipelines. So once again, there are major workflows. How do you identify the problem? How do you design around the problem? How do you then set up your project and provision things? How do you actually do the development work? You'll notice that a lot of this development work, very little of it is actually what you would consider classical data science. Instead, it's how do you analyze things? How do you build data pipelines? How do you connect to databases? How do you do basic software engineering? Then, of course, you've got regulatory issues, you've got ethical issues, you've got vast amounts of testing. We're building up practice areas that focus specifically on how do you do end user testing, system integration testing around machine learning systems. And then, of course, once it's live, you have to support it and scale it. And you have different teams that will do different bits and pieces. And of course, all of this sits on different technology stacks. So it's a vast amount of information to learn. And it takes some time to learn this. You won't learn it all in school, but you will learn it on the job. You'll learn the tools that your company cares about, and what source control tools you care about, what container platforms your company cares about, and how you want to scale and use things over time. So, what other skills do I need besides my degree? Well, domain knowledge, I've harped on this several times. You'll find this is important. Critical thinking, also important. Take those classes in writing, creative writing, analyze English literature, Spanish literature, do the deep analysis. Joseph Conrad's Heart of Darkness, always a great story to analyze. But critical thinking, we need people that show up with critical thinking skills. And you get those reading books, analyzing the books, writing papers on those books. Writing, communication, incredibly important, because now you're going from a scenario where you might work with 1, 2 people, and you're dropping people into a team of 50. You have to work on teamwork and communication skills back and forth. Hired this girl a while ago onto our team, and she'd never worked on a group project before, and she'd always done her development as a solo developer, and now she got dropped into a team of 55 and had to and struggled for a while to learn how to interact with the teams, communicate with other human beings around developing the project, and how to communicate status back and forth. Another important thing is storytelling. I was actually giving a talk to a company that does development, and I got a question around what's the one thing I could do better. The guy was asking, what's the one thing I could do better with data science and helping me explain it to upper management? I said, tell a better story. Because the stories have to always be contextualized in a person. So take your time to learn to tell stories. If you're going to try and explain about a human that has a problem and what they have to go through, and then you show that same human going through the new super cool process that you've designed and infused with machine learning, and wow, isn't it better? Tell it as a story, not a scary story like you might tell around the campfire, but a good story nonetheless. Problem-solving skills, planning, goal setting, achieving of those goals, and of course, self-awareness. You have to be aware of other people outside of our practice of AI. They don't understand what we do. My wife doesn't understand it, and I have to try and be aware. Sometimes I'm rambling on, and I see that glazed look, and have to go and explain why it matters and how it can matter. So self-awareness is one of those soft skills that we really need to bring to the table. Of course, there are hard skills to bring to the table, like containers. Learn Kubernetes. Did I mention it? Learn Kubernetes. Learn about containers. They're really important. We deploy our machine learning models into containers, and we have pipelines and DevOps pipelines that deploy those containers into our various environments and promote from development to QA to production or failover to our DR sites, and it's all done with containers. We used it, a few years back, we weren't using containers. Now everything is containerized. So dive deep into containers and understand those. Design thinking, there's some free classes in design thinking. Take a look at them, learn about them. It's a good skill to have. If your school offers design thinking, take the class. Did I mention take the class in design thinking? It's a worthwhile undertaking. It gives you a different point of view of how we now go about designing software and designing solutions for people. Security has become incredibly important. So now, before we deploy anything, it's all about security. We analyze, we automatically scan our codes for security problems, even our models. We look for things of that nature, and we push through security. So Important items. These are hard skills and soft skills. Many of you will be focusing on what are the hard skills I need to learn, but the soft skills. Everyone needs the soft skills to be successful. So back to this first slide. So what do I need to be a data scientist? So there's lots to this space. We've gone over this. Specializing, but learning about the broader space, even as far as learning architecture. You've got to focus on the not data science stuff, because you're going to be spending a lot of your time doing not data science as part of your job, whether you're a consultant, whether you're just hired in as an AI developer at some company. There's a lot of not data science that you need to do in order to be successful in that role. Be curious, critical thinking, design thinking as well, and software engineering. And of course, take a fun class. And in the comments, in the chat window, be sure to tell me what exciting classes you may, and silly classes you may have taken as part of your time here at the University of Louisville. All right, so please post questions, and I will answer those questions in the chat. Thank you for your time. I appreciate it. If you have any questions, drop me a LinkedIn. Always looking to see what's out there in the world. Love to have shared some of my time with you.